Well, in this last video for this lecture, we will utilize all the rules we learned in this lecture, and we will try to simplify these two expressions. As we discussed in class, several approaches can be taken, but we agreed that we will use the one that will get you to the final answer the easiest way. So we discussed that the first step we need to do to use the quotient rule for the radicals, and now place both the numerator and denominator under one radical sign. The quotient rule of radicals allow us to do this. Why would we do this? We are doing this with the goal to first simplify the numerical coefficients if possible, and secondly to apply the quotient rule for exponents. Let's first simplify the numbers. Both coefficients can be reduced by 3 or divided by 3. So 1 here and 100 there. And we can look one step ahead and decide whether we will have anything in our denominator. And apparently, after we use the quotient rule for exponents, nothing except 1 will be left in the denominator, so we just keep it, and we will have only 100, and the quotient rule dictates us to subtract the exponents, and then we will have 100 x to the 8th. 100 is a perfect number, and the power is an even number, so a very convenient expression under the radical sign. So 100 comes out as 10, and we just need to divide the exponent by 2, and that becomes 4. So this is our final answer. The second example is a little bit more challenging, but the steps are the same. So as the first step, we will put this big radical sign and place both. Again, this thing is popping up. I don't understand why. Okay, so we will place 50 x to the 11th and 32 x squared under one radical sign, and we will try to reduce both coefficients by 2. So 16 here, 25 there. Now, if we look one step ahead, apparently we will even after we use the quotient rule for exponents, we will still have 16. So now we cannot discard the denominator so easily. So we still have something, but please note that everything in the numerator and the denominator are still inside the radical sign, both. So, and we will have 25 x 11 minus 2. So that becomes 25 x to the 9th, 16. And we can either take out the square root of 25 and 16, or still simplify the variable and then take out everything. So let me still keep everything under the radical sign, simplify the variable, since it was an odd number, so I express it as a product of two factors. So be very careful what you're taking out and what still stays under the radical sign. So 5 comes out, x to the 4th comes out, since 8 divided by 2 is 4. X is still under the radical sign, this x, and 16 comes out as 4. So this is our final answer.